that. Share the screen. Okay. I got a couple of things I want to discuss today before we start the next module. So I have a homework assignment, homework 2, posted already. Please read that sooner rather than later, and let me know if it's unclear what is required, what I'm asking. So if I get questions about, where do you want these files to be located, please let me know as soon as you can so that I can update the text in the homework so that everybody knows what's going to be expected. All right, so I'm going to talk about command substitution first. This is a nice, useful feature that is provided by the shell. So it turns out that the shell will run any commands that are inside of $ and parentheses, and then it'll insert the output of that command into the command line as if you had typed it, which means that you can take the output of a command and insert it into the command line as if you typed it out. Now, the example that I'm going to use that this will be useful for is that if you wanted to get a listing of, or you wanted to run grep, for example, on a set of certain files, you could get the names of those files into a text file, and then you could do command substitution with cat. So for example, if you had a file that was named files.txt that had the list of files that you wanted to grep, or in this case head, if you do $cat files.txt, what the shell is going to do is it's going to run cat on that file name, which is going to produce a list of all of the files. And then it's going to take that list and it's going to put it into the command line as if you typed it there yourself. And so what we're going to use this for initially is a way of, for example, let's say I tell you to run grep on all of the files that end with .txt and are under a certain directory. Well, we know that the find command can be used to get a list of all of those files, right? And the find command is better for doing that than the ls* command because it will recursively go down to an arbitrary depth to get all of the .txt files. So you could first use find to get the list of the files that you want to run grep on, and then you could use grep with command substitution to look inside of those files for certain things. So let's see exactly what that looks like. All right, so I've got a sandbox for today posted. There should be a sandbox with today's date on it. Go ahead and download that if you haven't done so. And I'm going to do just a couple of command substitution examples, and then I'm going to talk about shell scripts, and we're going to immediately find a use for this command substitution. All right, so I'm going to go to my home directory first, in case I'm not there, and then I'm going to go into the sandboxes directory. It's already the 6th. Let's see what we have in here. All right, so I have some directories and some files in here. Now, there's a directory called log, and if you remember from last time, the find command takes several different options, but basically the find command it just allows us to find files or directories that match certain conditions. So this find command is going to look for all regular files, so it's not going to include directories, but it's only going to look for regular files that are underneath the log directory. So there might be several directories inside the log directory. This is going to list all of the regular files that are there. And this is what that listing looks like. So if I look at the very top, right, so I've got log/system/warning/user, and then this is the name of a file. So this is what's useful about the find command as opposed to trying to run ls, is that I don't know how many subdirectories there are, right? I don't know how deep the subdirectories go, and the find command will just recursively look for files in all of the subdirectories. And so this would be 1, 2, 3, 4 directories deep. If I was going to do this with ls, I would have to do a */*/*/*, but then that would only get the files in that directory. So this will allow me to grab all files that are in any directory. All right, so I have a bunch of log files basically. Some of these files end with log, some of them end with .txt, some of them are .out, but they were all returned by the find command with tacf or with tac type f. So these are all regular files. All right, so that's the find command. Now, let's use this to do some command substitution. So that's the listing or the output of find. let's take that output and let's send it to a file. So remember that the greater than sign will take anything that gets output by a command and it will put it in a file instead of printing it to the screen. So all I'm going to do is send that listing that I just looked at, right, that I just created, and I'm going to send it to a file called log_files.txt. Now, you do not need to retype out find log tac type f, right? You can use the history in your command to go up, right? So what I suggest you do is the first thing you do is you just get the commands to output what it is you want to the screen first, and then just go up in your history and add the greater than sign and then the name of the file you want to write this to. So I'm going to write that stuff to file. And the reason that I'm going to write it to file is so that I can then just use those files in command substitution and pass that to grep. So what is this grep command going to do? Well, we know what grep does when I give it file names. First argument is a pattern. So it's going to look for a pattern in the list of files that I give it. What are the list of files that I'm going to give it? Well, I either have to come up with a shell wildcard that has all of the files that I want to grep, or what I'm doing here is I'm just running cat on that text file I just created, which is going to expand into all of these file names, and then all of those files are going to be handed to grep as if I typed them all out at the command line, right? Which is clearly much simpler than actually typing them all out at the command line. Yeah, Tyler. Yep, so I'm looking for the string error in these files. So these are log files. I'm expecting that if the thing that created these log files ran into an issue, it would print an error message to the log file. And so this is a way for me to find all of the files first and then run grep on them. And I get a listing here that has all of the lines that contain that string. That's case sensitive. You can use tac-i for the grep command if you don't want it to be case sensitive. And so here's the listing. Let's see. Log system warning user, and it looks like March 25th. There was an error, something went wrong, but I don't know anything else because I'm not real. Oh, so the computer is trying to be funny. And that's what all of these error messages look like. So these are not all of the text files. So not all of these text files that are in here actually contain this error message. As I've said with the pattern matching and the expansion, right? So with curly brackets where you can expand into multiple arguments, you can always run echo with whatever it is that the shell is going to expand just to see what it is that's going to go into the command line. So echo is just going to take its arguments and it's going to print them back to the screen. So if I run echo with this command substitution, I will see the text that's actually going to be inserted into the command line by the shell, right? So I can see exactly what gets put into the command line. And this is the list of files that get put into the command line. Now this would take Joey, days. Yeah. I could assign him this for the rest of the semester and he might get halfway through it. Right, so this is a nice shortcut for allowing a lot of text to be input at once. Now, this is not the only way to do this. It's probably not even the best way to do it, but it's the easiest way to do it that we know of right now. And so that's what we're going to be learning in this class is how to progressively do these things more efficiently. So let me just, as an example, let me just go into one of these subdirectories. So there's inside the log directory, there's a directory called system, and then one in there called critical, and then one called user. And so if I run grep error star, I will get a listing of all of the lines that contain error that are in files that are in this directory. That's why I used the find command initially, so that I could get all of these. I wouldn't have to go into every subdirectory to run grep. And so I see that there's 4 of them that are in this directory. So this is a little bit more powerful than just using the pattern matching for a couple of reasons. One, as I keep saying, find will go through the files recursively. So it will find files that won't match a pattern that's just star.txt. But the other thing that is useful is that I can use find to sort of narrow down the files that I actually want to look at. Right? As opposed, I have more control over the list of files that get printed than I do if I just run ls with a pattern like star. So I could, for example, say, hey, let's only look at the files that are regular files, but also end with .txt. Let's only look at the files that end with .txt and have a size above a certain amount. Like the book has a section on the find command on page, I think it's like page 189, where they talk about several of the useful options for the find command. So the find command allows you more control over how do you filter what it is you're going to get listed to the screen. And then you can use this command substitution to run grep or head or whatever it is you want on all of those files. All right, so I'm going to go back up to the top directory of the sandbox. And I'm going to run the same grep command that I did before, but now I'm going to save the output. So I'm going to save the output to errors.txt. And then I'm going to use command substitution. Well, actually, this doesn't need command substitution. I'm going to use the word count command to count the number of lines in that file, which means this is a way for me to count how many errors there are underneath the log directory. It says that there's 24 errors. So I was able to first get a list of all of the files that are underneath the log directory, then run grep on all of those files using command substitution, and then count the number of errors by saving the errors to a file and counting the number of lines in that file. Right, so this is 3 tools that we're putting together to answer one question. How many errors are there in the log directory? Yes?
For some reason, every time that we've gone through these, I keep getting half as many results as you do on everything. Yeah, I got literally half. Like when you got 4, I got 2. When you got 24 there, I got 12. The amount of stuff that popped out when we ran echo was about half of what you got.
What files do you have here? So this is listing 2015 1230, 2016 412.
I have your first 2, not your second 2.
So these ones here you don't have?
Yeah. Right.
2016 714.
I concur. Yeah.
I'll have to look into that. I suspect something.
Maybe you changed it after you put it on your computer before you uploaded it.
Yeah, something like that. Or I did, what happened was, I think I know what it is. I've been doing this as practice. And so I've already untarred a sandbox, and every time I create a new sandbox, these dates are random. So I think what happened was I already had a directory that existed. I untarred it. It added files to that directory. It didn't remove the old files. And so now I've got 4 because these are randomly generated numbers. So if they were the same file name every time, then it would be the same. So I should have deleted my sandbox first. All right. So that's called command substitution, and it's very useful. And we're going to find a really good use for it today.
So how do you, where do you run it that it keeps auto typing for you?
This is a tool that I wrote that does this. So I save what I want to demo into a text file, and then I wrote a program that will read line by line that text file, put it into the shell, and then wait for me to hit enter, so that I can go at whatever pace I want to, basically demonstrate these commands, and not have to type live. That's the main thing, is that I make a lot of mistakes and I'll forget to demonstrate stuff that I want to demonstrate. So these are all just shell scripts that I've written, and that's what we're going to learn how to do now. Write shell scripts. All right, shell scripts. These are more powerful than it even seems initially, right? This idea of scripting is the #1 thing that's going to make productivity go up. So the fundamental idea is that anything you type at the command line can be saved into a file and ran later, right? So if ls is a command that I can type at the command line. That means I could save ls in a file, and then I could run that command from the file. Now, one command isn't that useful, but I could also I could save multiple commands in the same file, and then that script, when it ran, would just run the commands one after the other as if I had typed them out on the command line. That's what a shell script is. Now, this scripting is really the #1 thing that makes command line interfaces more powerful than GUI interfaces, right? So GUI interfaces are more useful for programs that you don't know how to use yet, right? And because you can see everything that the program's capable of doing, you can click on things, kind of figure out how it works. But programs like GNUplot that take a command line interface are easily, well, I mean, the GUI applications rarely have scripting ability. GNUplot automatically has the ability to be scripted because it reads commands from the command line. So that means you can create a list of GNUplot commands, save them in a file, and then tell GNUplot to run those. So you can have GNUplot generate a graph by just running one script. That's what we're getting ready to start doing.
What do you mean when you say GUI?
I mean, GUI is like this, the stuff you have to, it stands for like graphical user interface. Okay. So anything that's got buttons you have to click on, where you're not inserting text into the command line. All right, so there's 3 things that are required, and you got to get the first 2 correct, and then the last one is just how you run your script. And I'm going to point that out so that if you get this weird error, you'll understand what the error is coming from. So the first thing is that the first line in your script, so when I say script, I mean a text file that we're going to write. The first line in your script has to have the shebang. The shebang is this little hashtag #. That's called the shebang. Okay, so when I say shebang, that's what I'm referring to. There are other names for it, but that's the name that I use. And then the thing that comes after this shebang is the name of the program that's going to interpret your script. We are writing scripts for Bash. Bash is in the bin directory. So we need to specify that bin bash is the thing that is going to be running our commands. Now, if you don't know what to put in the shebang, you can always find where the actual program is using the which command. So which ls, for example, prints out bin ls. That's because ls is in a directory called bin, right? And we already saw that a while ago when we listed the contents of the /bin directory, we found ls in there. Bash, which doesn't look like it does anything because bash is the thing that I am typing commands into. Remember, I've said that the shell is the thing that interprets the stuff that you type in. Bash is the shell. So when I run bash, it just opens up another shell and says, hey, give me some commands. But if I exit this one, I get my original prompt. If I exit this one, it closes. Right? So I was running bash inside of bash there. So
you're just...
It's like an inception thing.
Kind of like our virtual machines instead of our
computers. Yes, exactly. All right, so which bash will tell me where bash is. Now, bash is one of those things that is almost, I mean, I've never seen it not in /bin. So /bin/bash will get you the bash shell.
What is that #! Exclamation point doing then?
The # is a comment. And this is like a feature. I don't know at what level it is. I think it's the kernel, but basically that is how the system determines what type of file you have if it's loading it up. So if it finds a # and an exclamation point, then it'll read the rest of the line and then hand off the contents of your script to that program. So it's like the system, it's just a convention that's used by the system for you to tell it, hey, here's the program that knows how to read this script, so give all of these lines to that program.
Okay.
What's really nice is it doesn't depend on the program, so you can put GNUplot in there, for example, and then create a GNUplot script that will run. All right, so let's do a shell script. Let's write our first shell script. The things that have to happen, I've already mentioned the shebang, right? You got to have this first line here, and that's got to be on the first line, and the # sign's got to be the first character. If you put a space there, it's not going to work. If you put a blank line above it, it's not going to work. The other thing that we have to do is we have to make the script executable. There's a command called chmod for change mod, I think. Change mod, I don't know what mod stands for, but this is what we're going to use to make the script executable. That's going to be important. And then when we run this script, we have to use the relative path name. So we got to put a / in front of the script. I'll discuss that when we get there. All right, so let's do this. Let's write a shell script to automatically download today's tarball. Now, Patrick's already done this. I know that what I'm doing is not the easiest way to do it or the most flexible way to do it, but it is a way to do it. So this is one that you should follow along, because now we're going to have a shell script where you run a command. It automatically gets the tarball for today's class and downloads it into the current directory. So every day you won't have to go to the website. You'll be able to just run this command and it'll download the latest sandbox if it exists. All right, I'm going to go back to my home directory. And what I'm going to do is I'm going to create a directory called bin. And I'm going to create a directory called bin in my home directory. And in this directory, I'm going to save things like scripts or programs that I write to do useful things. So this is just going to be my own personal collection of programs. There's a bin directory at the root, right? That's where bash is at. There's a bin directory in the /user directory, right? So these bin directories, it's just a convention for, hey, there's programs in here, right? I think bin probably stands for binary, which means these are binary executables that you're going to run. All right, so I'm going to create a bin directory. I'm going to go into that bin directory. And then I'm going to create a file called download tacsandbox.sh. The .sh is optional. What the .sh does is it indicates that this is a shell script. So .sh is often used to indicate that something is a shell script. I'm going to use Nano to edit this. You guys could use Pluma if you wanted, or you could use gedit, or you could use whatever it is you wanted to use, as long as it was a text editor and it wasn't something like LibreOffice. I would be using VI if I had my personal preference, but we don't want to get into VI yet. Maybe down the road.
Yeah.
It's very, very difficult to learn. It's a power user text editor. All right, here's Nano. First thing I got to do is I got to get my shebang in there. Okay, so let's type the shebang. #, exclamation point, space /bin /bash. Now let's get something in here so that we can just sort of see if it works. We're not going to write the script that does the download yet. Let's just get some stuff in here. And I've told you before that the echo command kind of seems pointless, but it becomes more useful when you start writing shell scripts, because the echo command is a way for you to print information to the screen that your script, it gives you some idea of where your script is, right? So I'm going to put an echo command in my script that says downloading sandbox. That way, whenever I run this script, it will print downloading sandbox to the screen. Now, the commands themselves are not going to be printed to the screen, right? It's not going to load the command and run it like the program that I'm using. It's going to run all of the commands and just print their output. So you're not going to have the actual commands that you write in this printed to the screen. So this is just going to print downloading sandbox. All right, so that's all I'm going to do. So let me exit here. I'm just going to hit Control X. Control X will ask if I want to save changes before closing, and then I'll just say yes. All right, save modified buffer. And I'm going to put Y here so that it will save that. And it's telling me that it's going to write to download tacsandbox.sh. All right, so I've got my shell script written. It has the shebang in it. That part's good. Let's just check and see what's in here. Okay, there's my shell script. There's only one file in here. I'm going to cat that just to see what it looks like, make sure everything looks good. Okay, it's got the shebang, and then it has my echo statement. This is me just nervously LSing things until I figure out what I want to do. Okay, so here's the change mod command. Change mod takes an option, and this option actually has a plus sign in front of it. And then it takes an argument, which is the name of the script. So what the change mod command is doing with this is we're saying take the file named download tacsandbox.sh and give it the executable permission. So make it executable. That's what the plus sign is. It's add executable permissions. What are the permissions, right? We've talked about this a little bit, We haven't gone through it in detail. This is discussed in detail in your book. But these things that are listed in the ls command are the permissions. So this R is read permission. The first set of 3 are the permissions for the person that owns the file. The next set are the permissions for the group that owns the file. And then the next set are the permissions for everybody else on the system. So my username is C. Clark. The permissions for C. Clark are read and write. That means I can read the file and I can write the file. I need to be able to read the file in order to run cat on it. If I didn't want to be able to run cat and print the contents of this, I would turn off the read permission. And then I have write permission, which means I can actually edit this file. I can write to it. I can either open it up in a text editor, or I could append text to it with the greater than sign. And then I've got the group, which the system, automatically creates a group that's named the same as your username. But you can imagine if we had a computer lab that we were all sharing, like, I don't know, this one. But let's say we only had one computer that we could access. That's how this, not like, only one terminal that we could go to. We had a computer with a bunch of monitors connected to it. That's just a mainframe. That's exactly what these systems were, built during a time where you had one computer and then multiple people could sit down and work on that computer at the same time. Well, then we would create a group called Fizz213, and then we could make files that had the Fizz213 group so that we could all share those files. And then every person could control what the group could see. And so this would be me, imagine that this was Fizz213 instead of C. Clark. Well, I would have read-write permissions to this file, but then my group would only have read permissions. So you guys would all be able to read this file, but you wouldn't be able to make changes. And then the last set of 3 right here is for everybody else. So somebody who's not in your group and is not you, what are they able to do? And this is saying that even if you're not in my group, you're able to actually read this file. All right, so we're going to set the executable permission using change mod plus X. If I ls tac l this now, here's what changes. These things that were tacs are now X's. That X means executable. So this file is executable by the user, the group members, and everybody else. That's what's required to make this a runnable script. All right, so let's run it. To run it, I need to do // and then the name of the file. So if you do /d, hit tab, it'll tab complete for you. And then you run it, and what happens? It says downloading sandbox. All right, did that work for everybody? Those are the 2 things that you got to have, the shebang and turn the executable permissions on. Now, try to give the name of the file without the /. I'm not sure, mine may actually work, and I'm not certain why. I think it has to do with the fact that I'm running this through a different program. But if you do this without the /, yep, see, mine works. So let me open up another terminal that is not my program that's running the script for me. So I'm going to go into the bin directory. Oh, by the way, LL is a shortcut for ls tac l.
I always thought that was 11.
It does look like 11. And if I try to run this without giving it // it works. Does it work for you guys?
No. Nope. No. Not found. Command not.
Yeah. Let me see what's going on here. I don't know. Well, the reason it's not working for you is because when you type something at the command line, the shell has to look for that command somewhere, right? And where it looks for that command are in directories like bin. So if I do ls, well, ls is in the bin directory. The shell knows to look there for commands like this, and so it runs it. It does not by default look in the current directory. So the directory that you're in is not one of the directories that is searched for commands. And so if you just type it without a // it's actually looking in all of these different system directories. And apparently I've got .bin, or I've got the current directory in my path somehow.
Yeah, it was that final one.
What's that?
That final one was telling you to check your current directory. See?
Where?
That was the second one in.
Oh yeah, it's the
You're
this
holding
was
for
really
like 8 minutes. Dude.
Oh, yeah, that's what it is.
yeah.
I've got the directory that I'm in. It's not that it's the current directory that's being looked at. It's that the directory that I'm in is in my list because I use bin for my executable. So let me do this. Let me go into temp. I'm going to copy the executable here. And now if I run it,
Maybe you do have it set to check your current directory as well.
well, we know it doesn't work for you guys, so. And then we're going to learn how to make that the bin directory be searched for commands. So if you get a command not found, I'm looking at UBS, because I imagine you being something like, it's right there. I see it. Why is it telling me it's not found? Because it's not looking in the current directory. You need to tell it that it's in the current directory with /.
So I figured out why I was doing that as well.
Did you?
Yeah.
Okay. All right, so // that's just the relative path name to a file that is in the current working directory. Now I'm going to turn off the executable permission if you ever need to. I mean, this rarely happens, but tac x, meaning -x, is going to turn off the executable permission. And now if I try to run it, so let's make sure that the permissions are off. If I try to run it now, I'm going to get a permission denied. Okay, so this is saying permission denied because the executable permissions are not enabled on that file. Don't think that, well, then I need to just run it with sudo because sudo is root and sudo can do anything. You're still going to get permission denied, right? It's not that you don't have permissions to run it. It's that this thing just doesn't have permissions to run at all. So you need to turn the executable bit on. So if you get that permission denied error, it means that you forgot to make it executable. There we go. All right. So let's figure out, let's write this script now. It's actually going to be fairly simple, but we need a couple of different commands that we haven't used before. The first one is date. So if you type date, it just prints out the date of that your system has. Does everybody say Monday, February 6th?
Yeah.
Okay, sometimes that can get a little messed up on the virtual machines. Does it really?
Yeah.
Well, yours is messed up then. This isn't going to work for
There's
you.
not even 31 days in February.
So you'll have to watch the video and follow along later. All right. The date command takes an argument, which allows you to sort of change how it outputs the date. And so plus %, capital Y will just print out the year, 2017. If I do %, capital Y, tac, %, lowercase m, tac, %, lowercase d, it will print out the year, month, and day separated by tax. So these % signs are actually going to be, date reads that in and says, okay, well, I'm going to plug in the year whenever I see %y, and then I'll plug in the month whenever I see %m, and the day for %d. And this plus sign is the format. This plus sign is what tells date that you're giving it the string that you want the format of the date to be. What's that?
Why is the Y capitalized when the others aren't?
Oh, there's a ton of options. We'll look at them. So this is the date format. That is almost identical to what the sandbox name is, right? The only thing that it's missing is a .tar.bz2. So this is how we're going to get the sandbox name that needs to be downloaded. So I'm going to run. This will answer. Well, I don't know if it'll answer his question, but it'll give more information. Turns out there's a command called man, which stands for manual. And the man command will open up manuals for other commands. So if I run man date, it will open up a manual page for the date command. Now, these man pages aren't always easy to read, but let's see what the man page for date looks like.
It explained why.
So
I checked it myself as well.
So you can see that, it gives you it tells you what the command does here at the top. Gives you an idea of how to run the command. This is a language that you have to sort of learn how to parse. This plus sign right here, right? So we ran date. These are options, and then there's a plus format. That's what we did. We specified the format string with this plus sign. So here are the different options that you can pass to the date command. And then down here is the listing for format controls. And so %A, %A, B, C, all of these have things that they correspond to in terms of how do you want to output the date. So %D will actually print out the whole date with the backs or the slashes separating it. %d is the day of the month. %E is the day of the month, but it seems to be space padded, right? So all of these are just different ways of printing out different pieces of the date. And so what the date command allows you to do is print out a string that contains date information in it. And this is what I use to format the name of my sandboxes. All right, so to get out of the man page, you just hit Q for quit. Yeah, exactly. Here's another inception moment. If you run man on man, you get a man page for man.
You get man.
You can just man as far as you want. Yep.
Just make a little army of men.
All right. So here's what I'm going to do. I'm going to open up Firefox. I can run Firefox from the command line because Firefox is just a command. And Firefox takes an optional argument. And if I give it an optional argument, what it does is it opens up the page that I'm pointing to. Right? This is just our class page. This is just to illustrate that, hey, the class page has a URL and we can go to it directly if we want. All right, so this is the class page. What we want is something that would automatically download this file right here, right? And this is a link. Now, if I look at this, if I click on it, it'll download it. But look at the bottom, look down here when I hover over this link. When I hover over the link, it gives me an address for that file. That's where the file is located. And if I wasn't, if I didn't have a browser that showed that, what I can do is I can right click on this and I can do save or copy link location, right? Copy this. Go open up another tab and hit Control V, and this pastes the URL to that file. That means that the file that we want can be accessed with this address. Now all we need is something that can download it from a remote computer using this address. If you go to that link and you right click it, you can paste that address into your terminal so that you don't have to type out what I'm getting ready to type out. Well, not that I'm typing it out. wget is a command that just gets files off of the interwebs. And so wget, the name of that sandbox, the URL, will download that file. So if you don't want to type it all out, and I'm looking at you, Joey, because I want us to get through this. Right click, paste. There it is. Okay.
What did you use? Save link as or copy link location?
Copy link location. So I hit that, prints out some information, says that it downloaded. Everything's good. All right, so let's download that. That's just to make sure that it works. All right, so the sandbox for today is downloaded into this current directory, right? This is the bin directory. All right, so this is a little trick that I often use. So I used the date command, and then, I always forget what the format controls are for the date command. So I end up having to type the date command out a couple of times to get the right format. We used this command, which means it's in your history, which means if you go up in your history, you can then modify that, you can edit that command line to echo the date command. And what you want to do is you want to echo this date command with single quotes around it. And all that's going to do is print the name or the command to the screen. Now, why do we want to do that? Because I can then echo that and send it to the file that I actually want that date command in, right? What we're gonna do is our script is gonna figure out what the name of the tarball should be using the date command and command substitution. So I'm gonna need that date command in my script. I don't wanna have to retype it all. So I'm gonna echo the date command that I used, and then I'm gonna append it to my shell script. That way, when I open up my shell script, it'll be in there. I can copy and paste it, move it around.
Could we not just update date plus like the original stuff?
What's that?
I guess not. Okay, so how would we go about appending a command directly without having to echo it first? And then,
You mean the actual text?
yeah,
You got to echo it.
okay.
The redirection here, which is the greater than sign, only redirects the stuff that gets output by a command. So if you want to get specific text into that file, you need to echo it.
Okay.
And then this is also in your history, right? So you don't have to type this all out. I'm going to echo the wget command. I'm going to put that in there. And now I'm going to open that file up and edit it. All right. So the second line here is my, let me maximize this. The second line here is my wget command. Here is the name of today's tarball, but I want this to be automatically calculated or inserted by the shell. So I'm going to do command substitution. I don't want to command substitute for the .tar.bz2, only for the date. And so I'm going to run in here the date command with the format string. So what's going to happen here? I can't see the whole thing at once. The shell is going to run into $ parentheses. It's going to take whatever is inside $ parentheses. It's going to run that command. It's going to take the output of that command, and it's going to insert it in here as if it got typed into the command line, or in this case, the shell. So I'm going to delete this. All right, so that's it. One command. Now, as long as I, meaning me running the website, don't change this link, your command is going to work. Or as long as I don't change the format of the sandbox naming convention, this is going to work. All right, so I should be able to Control X. Yes, I want to save. That's the file I want to save it to. Meta M.
Where did those parentheses close at?
What's that?
Do they close after the date command before the period in tarball?
Yes. Yes, before the period in tarball.
What are the formats?
What's that?
They're like Mac format, and there are a couple other formats in that it was saying.
DOS.
Yeah.
Those are the fact that the, yeah, this didn't get, hold on. So I want this, and then I'm going to run date. There we go. That's the referring to the difference in text file format for Windows machines and non-Windows machines. It's the difference between a carriage return and a carriage return plus new line. So on Linux, Unix, Mac, they just use a new line. On DOS and Windows, there's a new line and a carriage return. So if you've ever, yeah, you probably haven't. It's a real, like if you're moving text files to and from Windows machines, that becomes an issue. Like if you open up, what'll happen is like you'll take a file that you created on your Linux machine, you'll open it up in Notepad on your Windows machine, and it'll all be on one line. And that's because the carriage returns aren't in there, only the new lines are in there, and it doesn't print out the new lines. So that's just to tell you, for these end of lines, do you want to put a carriage return there as well, or do you just want to put a new line? All right, so let's try this. I think I've got it now. Yes, I want to save those changes. This is what I want to save it to. All right. So now, if I run it, so let me remove the sandbox. And now I should be, and let me remove the save file. And if I run it now, it looks like wget grabbed something. It told me that it was saved. So there it is, today's sandbox. We come here on Wednesday, you run this command, it'll download your sandbox. Now, I don't really want to save my sandbox in this directory, right? I'm in the bin directory. So actually what I should do is, let me delete this. I'm going to go into my downloads directory. And then I'm going to run the script by giving the relative path name to the script from the downloads directory. There we go. Yeah, it's really cruising. All right. One thing I could do if I wanted is I could modify my script to go into the downloads directory before it called wget, right? So if I in my script ran cd with no arguments, it would go to my home directory, no matter where I was at. And then I know that I could cd into the downloads directory. And then if I ran wget, it would download into that directory. So if you type cd and cd downloads right above wget, this will automatically save it in your downloads directory as well. All right, so shell script activity, which we're going to pick up on Wednesday. Write a shell script to untar today's tarball. Right, so you don't have to type TACX, TACJ, TACF, which is exactly why I would write a script to do it. I can't remember what all these commands are. And then write a script to download and untar today's sandbox all at once. And you can either write this as a script that does the two, or you can also just call the scripts that you just wrote. Right? So you have one script that downloads it, you have another script that untars it. Your script can then call those scripts to do work. Right? Your shell scripts can call other shell scripts that you've written so that you can do this stuff automatically. So when we get back on Wednesday, we'll work on a script that will download and untar the sandbox so that you're ready to go with one command. All right, does anybody want to say hi to Dinkle Little Star?